Before particles. Before light. Even before time truly meant something. There was expansion. Not in space, but of space itself. An unimaginable surge. A silent explosion. A phase we now call cosmic inflation. It was faster than light. Far faster. The universe grew from smaller than a proton to bigger than a galaxy. In a heartbeat. What powered this inflation? It's theorized that a field, the inflaton field, drove this acceleration. Its energy dominated the early universe, pushing space apart exponentially. With expansion, a new concept was born: time. No longer just potential, time became real. It flowed, like a new river forming through untouched land. The early universe was perfectly symmetric. But perfection cannot last in nature. A split occurred, the forces that were once one began to separate. The first to part ways was gravity, the weakest of the four, but the one that would shape stars and galaxies. Its separation changed the game. As inflation ended, it stored energy released, a massive burst of heat and light. A cosmic fireball surged across the newborn universe. The temperature, over 100 million billion degrees. In this fireball, the remaining three forces still held together. But not for long. Next, the strong nuclear force broke away. This was the realm of the quantum, wild, unpredictable, and foaming with fluctuations. Virtual particles blinked in and out of existence. The seeds of structure were forming in this chaos. For a fleeting moment, two forces were still one. Electromagnetism and the weak nuclear force. Physicists call this union the electroweak force. But soon, they too would part ways. Now, with four forces in place and the fireball cooling, the stage was set. What came next would change everything. Particles would form. Matter would rise. And the universe would take its first breath of structure. As the universe cooled to 1 billion degrees, something remarkable happened. Energy began to crystallize into matter. The first particles, quarks and gluons, emerged, swimming in a seething, hot plasma known as the quark-gluon soup. It was chaotic, dense, and unimaginably small. Yet this was the beginning of structure. As the firestorm cooled, quarks began pairing up, trios binding together to form the first protons and neutrons. For the first time, matter could stand on its own. These tiny building blocks were stable enough to survive, and they still exist in your body, billions of years later. But a violent balance existed. For every particle, an antiparticle emerged. Matter and antimatter collided in microbursts of annihilation, releasing pure energy. And yet, somehow, a tiny excess of matter remained. Just one extra particle in every billion survived, and that made all the difference. A few minutes passed, and the universe cooled enough for atomic nuclei to form. Protons and neutrons combined to create the first elements, hydrogen, helium, and a trace of lithium. These elements were born in a process called Big Bang nucleosynthesis, the cosmic alchemy that forged the seeds of stars. The universe was still hot, dense, and filled with blinding light, but that light couldn't travel far. Photons bounced endlessly off free electrons, creating a thick cosmic fog. It would take 380,000 years before the universe would become transparent, and light would finally roam free. That first free light, the echo of the beginning, still travels across the cosmos today. We call it the cosmic microwave background, a map of the infant universe. And from its faint glow, we have decoded the secrets of our origin. From nothing came energy, from energy came particles, and from chaos came order. The foundations of everything, stars, planets, life, were laid in these first few minutes. And yet, the story has only just begun.